Hello and welcome back to another episode of Effective JaRu, the series where we have a look at effective Java and see if we can port the items to idiomatic Rust, if possible. So, item 27 says favor generic methods. Why? Because this makes them more flexible, right? We can stuff in various object types in there and it might still work without explicit casting. And if it works without explicit casting, it's basically checked at compile time, which is a good thing, right? We don't want runtime checking. Want to prevent that as much as possible. In Rust, you have that by default. There's really no way around it. Java works a bit differently there, of course. So let's quickly skim through that. So that's basically how it looks if you want to have a generic method, right? You declare your type parameters and then you drop them in where you want them. And there's lots of stuff to learn about that in order to make it even more flexible. Something you also see is that if you use a constructor, because Java basically has close to null type inference, you have to type out everything. Wow, amazing. You would be so tempted to just say var anagrams is this, because the compiler obviously knows, but that's not ever going to happen with Java and they will not add it. But there is a workaround. You can have a factory method here, which is pretty much the same. It just drops a hash map of the given types, and then, look at this, then there is some type inference, but only then. Only then. They allowed that for some reason, but there's no more type inference. And that's quite, I think that's quite weak. I don't like it. Just because if you're used to Rust, then you know what type inference can do and how nice it makes the code look, without reducing any amount of safety or sacrificing any amount of safety, right? It just removes clutter from, stuff that you don't need to see. You can still type it out if you like, but you don't have to. Whereas in Java, you must. Yeah, I think, what kind of alternatives are there that run on the Java virtual machine? Java alternatives. What's this? Let's see. Really? I thought there would be a help that really shows you, or wiki JVM show which languages run on the Java virtual machine. Let's use the English one, shall we? JVM languages. Oh, incredible. Erlang, Rhino, Python, JRuby, Kava, JCL, expressly for JVM, Java Bean Closure, Groovy. I think Groovy is the one that is nice. Yeah, Groovy is kind of the modern version of Java. You can still do all the Java stuff, but it looks nice. So I think if you need to use, if you really need to use this, look here, type inference, right? A Groovy bean. And, well, you don't have to do anything, really. And I think that's how you want to write code. That's much more like it. So I guess in order to support my sanity, I would read something like effective Groovy. Effective Groovy. It's a slide at least. But hey, 108 slides. And it might have its roots in effective Java. Yeah, so it would be interesting to compare that to Rust, because I think it will be much closer to the comfort that you get. Maybe it's even more comfortable. Oh, look, a person builder. And that's the Groovy version, really? Really? Yeah, well, it's kind of struct initialization style, huh? The same goes, yeah, I don't want to digress too much, but I think it's very interesting. Okay, annotations. Stuff. Yeah, I don't understand most of these. Oh, what? Hash code. Always override hash code when overriding equals. Yeah, this is indeed one thing. equals in hashcode. Oh look, that seems a bit hacky. It's more like this would be more like a derive in Rust, where you explicitly state which traits you want to implement. But maybe it makes total sense for Groovy, so it's okay. Seems to be very special though, that's what I'm trying to say. Very specific, equals an override. ToString, yeah, so there is a ToString implementation that happens automatically. Oh look, favor composition over inheritance, yes. Yeah, that's very interesting. I think Groovy is something that's definitely worth looking at. Might be so much nicer to write that. And after all, that's important. But anyway, where were we? We were here, verboseness. Ugh. And that is another thing, generic singleton factory pattern. Yeah, I think now we can slowly dive into the code because there is an item 27 with plenty of examples from which we might be able to implement one or two. Yeah, returns the maximum value in the list, uses recursive type bound. Yeah, let's see what we can do here. Generic singleton factory. Generic singleton factory pattern. So we have an identity function that is an object version of that. So it's not even generic. But then we have an identity function that is generic that will just cast this thing. And that will then work. Okay. So this just applies stuff, right? This changes nothing. Let's compile and run. Basically just prints everything. Yeah, so it applies a function to an object and returns something. This seems to be more like a map to me, right? So if you wanted to do the same thing in well, okay, it doesn't even operate on multiple ones. Not implicitly. Yeah, let's just implement this in Rust, but I shall do it with unit tests. Then item 27. Why not? Cargo new item 27. Thank you. Item 27 lib. Okay, so we have, what do we have? It's a unary, let's call it unary closure. Okay, let's do it. Let's implement it. I wonder what I really want to do with that. It should be generic, right? That's the whole idea. So let's have a generic one then. Let's call it apply t, and it takes a t. Yeah, I think we want to own it then, huh? Item t and return t, and that is that. So that's our generic apply thing that actually does nothing really, and we obviously could use that, assert equal, and say, well, apply 1 is 1, and apply uta. I don't take it seriously, as you can see, so we just go ahead with a few examples and have that. And here, well, let's simulate that. So if you have a few numbers there, then we could as well, we could inspect that and just print them out using using apply as closure. That should work. We could map them. Yeah, I'm not sure because it's so useless, right? Oh, okay, let's have a numbers array then. Oh, interesting. That's how you I didn't know. Did you specify inline arrays like that? I had no idea. I've seen it only with brackets, but not with curly braces. Anyway, in Rust you do it like this. 1, 2. Oh, different types. That's that's objects here. Look at that. So then we actually have a tuple that we would have to destructure. We couldn't iterate that anymore. Yeah, funny. So in Rust you couldn't do that, obviously, because these are actually objects here. So now what? Could be a tuple, but that wouldn't make too much sense to do it that way. We could just boil it down to floats, because it all doesn't matter. Yeah. There is a number trait, I think. We could really try that. Let's see if there is a number trait somewhere, maybe even in a different crate. There is a trait like that. Let's see. Crates.io num. Just for that nonsense, I even look it up. But this is the standard number crate, and there might be traits that are interesting for us. No. I meant to get to the documentation. Show me your traits. Complex rational traits. Bounded. Checked float num, the base trait for numeric types. Okay, let's see what this thing can do. Yeah, can't do much. So with that, we couldn't even, we can work with apply there, but we couldn't do much more. Yeah, let's try it. So let's see, as box, so we have, we need this extern crate now. Gee whiz, extern crate num to simulate that, right? So we want to have numeric objects here, and because they have different sizes, we have to put it onto the heap, which is a waste. We wouldn't want to do that, but we try to simulate that. So let's try it. Let's pull it in. Dependencies num in whichever version you like. Oh, come on. So here we go. The first build will now take a moment because it has to pull that and compile it. So use num traits num. Maybe there is more. Maybe there's something better. I see. So we can, if we wanted to do more, we could. We just had to say, well, we need to support other things as well. Oh. That's bad timing. Oh well, so let's keep trying here. Did that succeed? Yes, it did. Cargo test. And yeah, let's try to get that to work here. So we have a box new of yeah, I wonder how that works actually. Maybe that is happening automatically. So we have let's say we have an I32, then we have an F32. F32. And we have a box new, what is this? A long. So let's make it 3U size. Good. So that should now be a valid slice of box nums, but maybe, wait, stop. We want to have this, right? So we have 3 items here. Huh. Does that work? I have no idea. No. Okay, cannot convert to a trait because trait num is not type safe. Is not object safe. Maybe something else is there. The value of the associated type output from the trait mal must be specified. Oh, okay. So there's more. I'm not sure if... So these mal things, I think they're part of the standard library. So here we have an output trait. Let's look again at num. I have the feeling that num requires a lot more. See, num needs partial equality, 0, 1, add. It sets the output accordingly already to itself. But maybe I'm specifying it incorrectly here. Maybe it's just a matter of how you specify this. Do I have to specify all of that here? Do I have to? That should be implied, right? And it seems to be implied by this, and I would expect this to work. That's interesting. I never tried that, obviously. And apparently that isn't working. Maybe it I don't think this figures it out itself, huh? Because it's all different types, but maybe it does. We shall see. Yeah, so mismatched types. It wanted to have an I32. Found something else. Maybe we have to cast it individually as box num. Maybe that will now set the tone here. Okay. Reset. Let's try again. Okay, so it has the same problem basically. We could do it individually or for the entire array, but we would always have this kind of problem. Mal sub add. I wonder why this is, because it looks like these are already identified and they default to self, which is kind of exactly what we expect here. I'm not sure what I'm seeing here. I mean, let's how can I specify this? Maybe there is an error code that I can use. Rust C explain. Not yet. Maybe with the nightly you have more. Let's use a nightly here. Multi-rust override nightly. Okay, there we go. Trait object needs to have all associated types specified. Yeah, so but num itself has no associated type. This is something I know, but in this case, maybe it is only about this one type from radix error. It's a bit, maybe there's another one that we can use. Maybe we can use just one that we don't care about at all. That is simpler. Like one returns 1. Needs mal for some reason. Let's try 1 then. Let's see. Have to rebuild a few things now. All right. Takes time away, but yeah, what can you do? Come on. Good. So the value of the associated type output from the tray must be specified. So it's the same issue. Somehow it doesn't want to do it. No. Okay, I'm actually willing to give up. I don't know how to specify a type that you depend on. Is it like use std ops mal, and then you say, well, mal output is self? Is that valid? No, it's not, because I've never seen that syntax before. Also, that shouldn't be valid. Yeah, this doesn't even have an own associated type, yet it's depending on this and it doesn't get it. Maybe it just can't be used that way. Yeah. Use self outside of an implement trait. Yeah, what if I say I32? Then it's probably oh, it's still different types though. If I have I32 here and here I have usize, then I cannot, it's still probably not possible to have all this in the same array, right? And the whole idea is that we bring it down to kind of one shared thing and to put it behind one Virtua or one fat pointer. So primitive, maybe primitive, too primitive. Maybe this will do for us. That could do, but we lose type information that way. To own, we could use to owned. Where is that defined? Oh yeah, obviously it's not defined here. It's defined here. Yeah, I think this is something we could do, possibly. It's interesting the way it's implemented with borrow. It's a borrow of self and then anyway, this might work for us, but on the other hand, too much time has been spent on this already, 23 minutes in, and you know what? I give up on this one. You got me there, Java, but it's merely me who can't do it. Okay, there's no good reason to explain this. I don't know how to bring a number down to something onto the heap. I don't know. Maybe there's a super simple way that doesn't involve serialization, but that is something I just can't do now. How to bring numbers of varying types onto the heap into the same array without using a enum. You could have an enum for this, right? But it's still not the same that you have here in Java. All right, so generic static factory. What can you do? All right, that's the way to have type inference, huh? Let's show off some type inference. Okay, we can kill all this and item 27 cargo. No, cargo Tomo can kill that as well. Okay, so now we go with type inference, generic static factory. Yeah, it's called a type inference. Okay, so this one creates a hash map. Yeah, might as well pull it in here. Use std collections hash map. And well, let anagrams be Yeah, let's make it so. Anagrams, string, a list is a vec of strings. B hash map, new. There you go. And that is it. Nothing more to be done here. Of course, we can't do much with that right now, but it just shows how type inference works. If you would add something, we wouldn't even need this. Then we could just have it have the type, or let the type be inferred by, yeah, let's have it. Let's show anagrams. Let mod anagrams 2. Well, actually, we could do it like this. Be a hash map new. And then we insert something which shall be hello or a, and this would be a vector of probably just a, right? So that would work as well. Unused variable, true. Can we use it somehow? Maybe we can print it or something. Print it nicely. Anagrams. Yeah, we will not see anything, but we will also see no warning now. Cool, so that's very nice. That's the Rust version. Recursive type bound. Recursive type bounds, I think they happen if you say that T must implement a certain interface that also is specialized for T. So that is that. Let's implement this main. You know, let's focus on the functionality here. And we call this, let's call this max computation. Let's see. So we have, do we have something? Oh, we take arguments here. So let's use a vector of strings. Let args be string slices in this case. That's more efficient. Foo bar buzz. 1, 2, 3, 4. There we go. And now what's the maximum value? How do we implement this? Actually, do I need a vector here? I don't need a vector. I don't have to simulate their list here. We can also just take an array like that. And then args either. Do we have a max by or something? Is this stable? I don't know. Actually, I would like to use stable again. Multi-rust override stable. Let's test it and let's see if we have a max implementation. Somewhere, max by, that's the one. Iterator max by. It's unstable, may want to produce an ordering directly. Min by. Can we simulate this somehow? Like with fold? I think this could be simulated with fold, huh? If we would... Yeah, let's do this. Let's try it. Because I don't want to use unstable code. Unfortunately, the max implementation will not be that awesome. Then what's coming out of here? Yeah, well, we have a different input set, right? Oh. No such element exception? Abstract list, either next. Oh, because this thing tried to run it without an argument, huh? I don't know what's part of the arguments array, but there should always be one. And I think the problem here is, yeah, next was called on an empty something. I do still wonder why there's not at least one in there. So where did it happen? In Java 12, here. Interesting, so that's totally empty. Yeah, why don't we set up something ourselves, arrays as list? How do we get a list here? I have no idea. Phew. I think I should know that, huh? I think arrays has some constructor here from args that allows us to do that somehow. Yeah, so what's part of the args, by the way? That would be interesting. Oh yeah, unfortunately you have to rebuild it. Something like build and run is not part of Javatar. So it's a... I don't know what that is supposed to mean here. So it's a string at this. It's a single string, really? Unexpected. I thought string could print itself nicely, but maybe it cannot. Maybe I'm getting it all wrong. Pretty print, printf. Oh, well, I don't have a format here, so not like this. Yeah, well, probably it wants to tell me that it's a string array, huh? Which is what this is. And it doesn't pretty print it for me. Well, yeah, that's a nice implementation. Doesn't even work here. I would at least expect it. Yeah. So can we provide args? I don't think so. Can I push args? I don't think so. Slices are immutable here. So no pushing. I would like to initialize this with a list like that. Initialize string array list. Java string array literal. Show me. Show me, Google. How does it work? New int. That's how it goes. Okay, cool. Actually, I've seen that before, and I'm dumb. So that is that. String. Can I just override this? It's not final. I should be able to. So now I can say foo bar buzz 1, 2, 3, 4. We convert it to a list, and then we drop it in there, print the results. And let's run it. Come on. Of course, we want to build it first. I find that relatively cumbersome. Maybe. Oh, no, it doesn't like it. Why? Variable args is already defined in method. Yeah, but I can just rebind it. It's not final. Can I? What's the problem? Man, hatred. So you cannot rebind arguments. Is that what we learn here? No matter whether they are final or not. Huh. Okay, so foo is the max one. Really? That's interesting. And also, I don't know what compare to does. I think it returns negative values. Oh, it's interesting. Yeah, I'm not sure if you can emulate this. I don't even know why this always returns the first one. Can I do something that makes it return something else? Like an empty string? Buzz. Well, something happened. Now buzz is the maximum one. If you say so. Using strings is probably a bit awkward here. But maybe we can use numbers and we will be happier that way. Let's use auto boxing as well. 1, 2, 3, 4. Arrays as list, args2. Now we have a number in here. One more attempt to get this right. There we go. And now it should also work as before. No. But now for real. Compile it, and it hates the world. What? Type does not conform to declared bounds. Oh, compared to is not method max in class recursive type out cannot be applied to given types. Interesting. So apparently number does not extend comparable. Okay. So considering that this doesn't work, I just skip it. Bang. Doesn't actually work in Java example either. So let's not waste time on it, huh? We've been wasting a lot of time on this one. Unary function, okay, that's just required to make Java happy because every class, every public one must be in a separate class or Java file. And the union, that's a generic union. How is a union? I wanted to say union implemented like a C++ union. No, it's just a set union. Yeah, so let's try this. Let's run it. Mo, Harry, Tom, Curly, Larry, Dick. That's what we expect. Kind of maybe not in that order. Okay, so let's implement it. That's cool. Test union. We obviously are just going to use standard types here. We are not going to use our generic union thing. I think Java obviously will have its own implementation for this that is generic. But considering that, you wouldn't write that code in Java. And yeah, I will just use the standard one. Use std collections hash map. And then we have a hash map from, oh no, it's a tree. How was that type called again? How was it called? I'm always forgetting something with tree set. B tree set. What kind of sets do we have? I think I want a B tree set. B tree set. Because there we can now easily simulate this. Unfortunately, we don't have initialization. We will have... Oh, wait. I think we can do it. Because this implements from iterator. And what we can do is the following. So let guys be a B tree set with inferred type, because the type is kind of, you know, it's nothing we have to provide. And then we have an array of things, of string slices to be precise, Dick and Harry, and we say either collect, and this should be enough to get a B tree set from an iterable. Collect is your friend. Borrowed value does not live long enough. That's interesting. Can we do an into either? So it seems this is a temporary value, really? It seems to keep borrows to slices here, but I want to consume this. I want to drain it, but I can't really drain it. Yikes. Does it work with the vector? I'm curious now. So what about this? Look at that. Because now it's consuming the vector. But also I feel it might be a bit more inefficient because we have a temporary vector here, which worst case will allocate just to deallocate a second later. This also means that we need either into either here, huh? Yeah, because that really drains the vector. Okay, so we have guys, and what else? Stooges, Larry and Mo and Curly. Cool, and then we form a union and print that in a nice way and say guys and Stooges. I think this is implemented for the hash set or the B-tree set. No, it's not implemented. I thought it would be. It has some interesting implementations. We can definitely have a union, and I was thinking this implements certain. Here's sub, bit XOR, bit AND, bit OR. It's implemented. So why is it not implemented? Do I have to call it? Well, if I call it, then I can as well call the union directly. Union Stooges. And that should work then. Mismatched types. Oh yeah, it wants to have, probably wants to have a borrow to that and doesn't want to own it. Oh no. Collections B-tree set union doesn't implement debug. How come? What's a union anyway for him? What's this union type? Can we make it printable? It has clone, it has iterators. It seems because it is an iterator, so we would have to collect on it in order to print it. All right, collect a vec of the type that you infer, and that shall finally print something. Yeah, so some lesson learned in Rust. You might want to assert false here just to get the printing. One lesson learned in Rust is that lots of things are actually using iterators, so it's lazy, right? Lazy computation is key here because that actually allows you to handle huge data sets, because you don't need to, have one step of your transformation in memory all the time. And that's a good thing. But this also means that sometimes if you want to print everything, like in this demo, then you have to kind of jump hoops and collect into a vector first. But even that is easy. I wouldn't mind at all. Cool, so that is that. I think we're spending enough time on this item here. Some things don't really apply, but this is kind of the code that you would need to make this work. It's kind of interesting to see how this works, how, I don't say difficult, but how complex it can be sometimes to initialize something with literals, even though in the common case you don't have that you don't usually have that, because that's not how programs work. You don't just initialize that. And if you do, maybe you could write a macro that would do it for us and just pushes this. But it's, of course, always a runtime thing, right? And this runtiminess is represented here. Here, of course, it's also very runtimey because we create a list, an intermediate list from the arguments as list. Oh, that's the one that I was looking for last time. And then you create a hash set from it, and then you work with that. So even more effort there, I guess. So yeah, that should be it. Thanks for watching, and have a great day.